Hi, I'm Stephanie Thornley, and I'm here with Richard Bacon, Zach Pinfold, and Schwam Mack to tell you about our blooming good app, Budding. Our app can measure a plant's height and track its growth using a mobile phone and the measurement of the real-life pot height. I personally have a backlog of old plant photos in my phone, which I manually compare against each other to observe their growth. So this app was inspired by wanting an efficient and easier way to keep track of our plant's progress. While there are currently many apps that can identify a plant, or remind you to water it, we had not yet come across one that could measure it and track its progress. This app is for anyone who wants to find out just how green-fingered they really are. So, let's get growing! When starting the app, you can either log in using an existing username or sign up. Because we have no plants yet, we will be prompted to add a new plant snapshot. As a new user, I don't yet know how to use this app, so I can select tutorial to be taken through each stage step by step. First up, how to take the picture. This details the perfect way to take a photo of your plant, which will get the most accurate measurement of the plant's height. Position the phone midway between the top of the plant and the bottom of the pot, and at about a 90-degree angle. The user should not take the photo too close. The plant and its pot should be positioned in the middle of the screen, as shown. We also provide some photos demonstrating what a good photo looks like and things to avoid. We then tell the user we need the real-life measurement of the plant's pot, from the base to the top of the rim. We need this measurement to be able to calculate the plant's height. We also inform the user that they are able to change the plant's pot height in future if they want to. Finally, in step 3, we guide the user through how to use the measuring screen. This shows a GIF which demonstrates parts of the photo which need to be aligned with the markers: the bottom of the pot, the top of the pot, and the highest point of the plant. We can then go straight to measuring a new plant. We have the option to take a photo or pick from gallery. Here I'll take a photo. I'm happy with this photo, so I'll select Use Photo. I then need to give it my pot height. The user only needs to input their pot's height once, as the app will store and use when the user adds more plant photos and measurements. And this takes us to the measuring function. Here, I place the first marker on the bottom of the pot and press Add First Marker. Then, I place the second marker right at the top of the front rim of the pot and press Add Second Marker. Lastly, the third marker at the top of the plant and press Add Third Plant. If I decided I wanted to redo the marker positioning, I could press Reset. I can now press Submit, which will take me to the form to enter information about my new plant. All fields are required, except watering frequency and soil, which are optional. Here, I will only add watering frequency from the optional inputs. Then, once I've added my new plant, and it has been successful, I will be taken back to my garden where I can see my new plant and its height.
Now we'll run you through the app from the perspective of someone who has previously signed up to Budding, and show you how easy it is to view and edit the plants you have already stored. After logging in, you're going to land on your garden page. This displays all the plants that you've stored in your app already. You can sort through your garden by newest or oldest, how many snaps you've taken, or by plant type. We're going to check out the herbs today. Minty's been growing for a while now, so let's remind ourselves about how she's getting on. I can see its information displayed on the plant page, look at some recent snapshots in the carousel, and I'm going to head into the All Snapshots page to see the plant's growth over time. We can see it displayed clearly on the graph above, and we can check out all the images stored in the database from when it was started growing. My rosemary plant has started to grow a lot since I last took a photo, so I'm going to take a new snapshot so we can track its growth. After selecting new snapshots from the plant page, I'll be prompted to take a new photo. After confirming, we already know our plant's pot height from when we stored it before, so we'll move straight onto the measure page, which is set up exactly how I remember it from before. The plant's height will now be updated across the app. And I've decided to move this plant from the outside to the inside, so we're going to need to update its information. That's easy. I head back onto the plant page and select the edit button. Effective UI makes it easy to navigate to the correct form, where I simply switch the data from outdoor to indoor. If you decide to pass on your plant on to a new friend and no longer want to see it stored in your app, simply head into the plant's page and hit the delete button below. Thanks for watching. Now on to some more details about our tech stack.
Because we know how big the pot height is in centimetres, by measuring the height of the pot in pixels, we can calculate a scale of how many pixels are in a centimetre. We then use this pixel to centimetre scale to calculate the plant height using the pixels we obtain from placing markers at different points on the photo of the plant. When we place our markers, the screen detects the coordinates of the position of the marker. By storing the screen's y-axis coordinates from the bottom of the pot and the top of the pot, then calculating the difference between these pixels, we can use the pot height in centimetres to calculate how many pixels are in a centimetre. We then measure the pixels from the top of the pot to the top of the plant and calculate the real-life height in centimetres using this scale. If the photo has been taken correctly, the plant height is accurate to within a few millimetres.
We wanted our app to function properly across both Android and iOS, so we decided to build our app in React Native. We had used React for a previous web project, but as we discovered, React Native is a completely different framework to work with, and came with its own learning curve. We identified a lot of functionality within React Native that would be extremely useful for the functions within our app. For moving the elements around the screen and tracking the plant's height, we used Pan Responder, an inbuilt React Native gesture controller, which allows us to use the screen coordinates to calculate the height of the plant. When building the tutorials, we were going to use GIFs for the animations, but we found the visuals to be grainy and not a good fit for the look of the app. React Animations is built into React Native and allows us to create smooth animations with SVG files and style components. React Animations had a steep learning curve, but we managed to get it working on a looped animation to effectively illustrate the tutorial screens. For capturing the images, we used the React Native Image Picker. We then use Amazon's S3 buckets to store them. React Native charts were used as a clean way to display our plant's growth progress over time and integrated seamlessly into our app.
So we decided to use Expo's built-in tools, and with that we were able to visualize and test our application for functionality throughout the building process. It also helped us to understand exactly how the app would perform on both Android and iOS devices. And also we wanted to mimic the kind of environment we'd find ourselves in when faced with a commercial project. So when it came to styling, we actually decided to work off a design specification built in the Adobe suite. This meant that instead of simply being happy with where things have been placed in the app and leaving them there effectively, we would have to utilize our own styling skills to ensure the app would have looked just as the client might have intended. Not only does this help to develop our styling skills, but also allows for some basic prototyping in the app's design in the early stages, which gave us a really good opportunity to build on the user experience and the user interface. Now over to Richard for some back-end tech.
In terms of back-end technology, we have a Node.js app which runs an Express server and communicates with a PostgreSQL database using Connect.js. All of this is hosted on Heroku. We're also using AWS S3 to store any images that have been uploaded by the user. Our app serves API endpoints, which the front-end uses to perform CRUD operations on the database. We chose SQL because we felt that it was most appropriate for our application. Our data is well structured and relies on the use of quick queries to pull data in efficiently. Our back-end technology choices reflect the fact that we were trying to strike a balance between learning something new, but also using technologies that the team were familiar with as a whole. We realised that our app is fairly front-end heavy, and so we prioritised our time accordingly.
Though we were happy that our choice of tech would be suitable for our app, we did run into some difficulties. When it came to measuring our plants, bigger plants, of about 30 centimetres or more, were less accurate. The accuracy can be thrown off if the photo is not taken from a 90-degree angle, as the difference between the 3D plane in real life and 2D plane on the photo can throw off the perspective. However, we were happy with our simple solution of measuring using a scale, as this gave us the same degree of accuracy to augmented reality if the plant was not taller than about 30 centimetres or more. During development, the different development environments amongst our group made it trickier to view our app together. 2 of our members were using iOS, the others Linux. This meant we could not use the same development environments, which included the emulators which showed us how our app works on an actual phone. For iOS users, they could emulate a virtual phone on their computers, whereas Linux users had to run the app on our actual Android phones, as virtual emulators for Linux took up too much memory on our laptops. This meant that, during pair programming, we could not view our app on Android together. However, there was an advantage that it meant we could see how our app looked on both iOS and Android, which helped us a lot when it came to styling our app. We also gained a better understanding of the challenges of developing an app for both iOS and Android, and how developing an app for one or the other might differ. The most notable difficulty we had when using React Native was understanding how different the React Native navigation was compared to any routing we had previously used with other tech. As we have about 15 different screens on our app, it took us longer than expected to feel comfortable with how routing works on a mobile app. However, we were pleased we were ultimately able to set up navigation in a way that gives a good flow to the user experience.
Learning to work in an agile environment was always going to be a new challenge. Having to do this remotely in a group setting while building an app from start to finish came with its own unique set of learnings. We scheduled regular stand-ups throughout the day to ensure we were all on the same page about the direction and progress of the app. Pair programming was utilized throughout the app build to ensure everyone was learning new skills and helping each other overcome obstacles. Pairing was switched up throughout the app's build to keep everyone integrated. Overall, we were really happy with how we worked collectively on this project, especially given none of us have met in person. The fact that we were able to build a fully functioning app in 2 weeks gives testament to our skills as an effective team.
We're very excited about the potential of our app, and we have some ideas for further improvements. Specifically, we'd like to add to our infographics page to allow the user to track other aspects of their plant which might affect its growth, for example, watering frequency or soil type. Other potential improvements also include user authentication and the addition of an overlay on the camera viewfinder, allowing the user to take better images and improving the accuracy of measurements taken. Overall, we're very happy with what we have achieved as a team. Thank you for watching our presentation.